Hi, and welcome to Physics Fundamentals. I'm your host, Angie, and today we're looking at the physics of propulsion and Newton's third law. Thrust is the force which moves any aircraft through the air and is generated by the propulsion system of the aircraft. All thrust is generated through some application of Newton's third law of motion. For every action, there is an equal and opposite reaction. The three laws of motion was first stated by Isaac Newton in his Mathematical Principles of Natural Philosophy, originally published in 1687. The third law states, if two bodies exert forces on each other, these forces have the same magnitude but opposite directions. By developing his three laws of motion, Newton revolutionized science. We know that the first rockets were developed in ancient China. Modern rocket engines that lift spacecraft into orbit operate on the same principles. Key to the development of the early Chinese rocket was the invention of something similar to black powder, a mixture of saltpeter, charcoal, and sulfur that burns rapidly and fiercely when ignited. This black powder used by the Chinese was a form of solid propellant. Firework displays use a similar solid propellant. Dr. Robert Goddard is considered the father of modern rocket propulsion. NASA's Goddard Space Flight Center in Greenbelt, Maryland, was established on May 1, 1959 in his honor. In 1926, Goddard constructed and successfully tested the first rocket using liquid fuel. The flight of Goddard's rocket on May 16, 1926 in Auburn, Massachusetts was as significant to history as that of the Wright brothers at Kitty Hawk. In 1914, Goddard received 2 U.S. patents, one for a rocket using liquid fuel and the other for a 2- and 3-stage rocket using solid fuel. On the morning of December 17, 1903, the world's first successful aeronautical propulsion system, a gas engine, propellers, and the equipment needed to make them operate, took to the air on the Wright Flyer. The aeronautical community continued to refine the system until the introduction of gas turbine engines in the 1940s. Now we're going to take a question from a student named Ziva. Ziva, what's your question?
Hi Angie, my name is Ziva, and I'm 10 years old, and I have some questions. I saw a YouTube video of someone using a skateboard with a fire extinguisher, and they were going very fast. How does that work? Is it the same principle as a space shuttle going to space?
I know just the person that can answer your question. His name is Bob Pelcovits. He is a professor and researcher at Brown University. He loves teaching and helping students appreciate the beauty of physics. Bob?
Excellent question. In fact, the fire extinguisher held by a person on the skateboard is just like a rocket engine. I thought of doing this demo myself, standing on the skateboard, holding the fire extinguisher, but on second thought, there was no way I was going to do that. So instead, we asked an expert skateboarder to show us how it's done. So why does a rocket or fire extinguisher move when gas shoots out the back? You might think it's like a person walking. The person pushes back on the ground with their feet, and the ground provides an equal and opposite force via Newton's third law, pushing the person forward. You might think that a rocket moves because the gas coming out of the back of the rocket pushes on the air behind the rocket, and the rocket moves forward, just like a person walking. But wait, does this mean that if a rocket is in space, where there's no air behind it, nothing for the gas coming out of the rocket to push on, then a stationary rocket could not move, and a moving rocket could not change its speed or its direction? 100 years ago, before rockets were built, a famous newspaper made fun of Robert Goddard, the father of rockets, who proposed sending a rocket to the moon. The editorial said something to the effect, "This is ridiculous. This rocket cannot get to the moon. There is nothing in space for the rocket to push on. Newton told us hundreds of years ago about action and reaction. If there is nothing in space for the rocket to push on, the rocket cannot move. If the rocket can't push on something, it can't start moving and it can't change its speed. We know now that in fact it was this editorial that was wrong and ridiculous, not Goddard's vision of rockets. You can send a spaceship to the moon, and the spaceship can adjust its direction or speed by firing small rockets attached to it. Also, astronauts can use a portable rocket pack attached to their backs to maneuver outside a spacecraft. So what gives? How does a rocket move in space? How does it begin to move? How does it change its speed or its direction? What is the correct explanation for why the skateboarder holding a fire extinguisher is able to move? Well, the correct explanation still involves Newton's laws. It's amazing how much Newton understood about our universe. We just have to use his third law correctly. Let's draw a picture of what happens when gas comes out the back of a rocket. The rocket is exerting a force on the gas it pushes out. But now, Newton's third law tells us that the gas must exert an equal and opposite force on the rocket. Let's add these forces to our drawing. The force exerted by the gas on the rocket pushes it forward. This is the essence of rocket propulsion and how our skateboarder moved holding a fire extinguisher. Seems simple and straightforward, but remember, highly educated editorial writers got this wrong 100 years ago. So now I will demonstrate the principle of rocket propulsion. I'll use a fire extinguisher, but rather than taking my life in my hands standing on a skateboard, I'll sit on a stool. Here goes. Whoa. So how is walking different? When we walk, we push on the ground. We don't expel hot gas from our feet. Our mass doesn't change as we walk. When a rocket moves, it is pushing hot gas out the back, and the force that it exerts on that hot gas, by Newton's third law, leads to a force of the gas on the rocket moving it forward. Simple to state, but subtle. We have to be very careful when we apply Newton's laws.
Okay, I understand. So, is it physically possible for a bus to move with 100 fire extinguishers attached to it?
First, we need to understand what force opposes the motion of the skateboarder or the bus. Why couldn't someone just blow on a skateboarder and make them move? Well, in fact, the force opposing the motion is friction between the wheels of either the skateboard or the bus and the ground. For the skateboarder, the force produced by the single fire extinguisher expelling gas is larger than friction, and the skateboarder is able to move. We expect that a single fire extinguisher can't make a heavy bus move, except in space, where friction is very, very small. Why does the weight of the object matter? Because the weight of the object indirectly determines how big the force of friction is. The force of friction is proportional to the upward force of the ground on the bus. Newton's second law tells us that because the bus is not lifting off the ground, that upward force must equal the weight of the bus. So as we expect intuitively, it's harder to move a heavier object than a lighter one because the force of friction is greater. I Googled the weight of a school bus and found 25,000 pounds. That's at least 100 times more than the combined weight of a skateboard and skateboarder. So while 100 fire extinguishers might make this work, let's make it 150 just to be sure. Great intuition as to how many fire extinguishers are needed to move the bus.
Thanks, Bob. And thank you for watching. If you're a student and have a question, please email us at physicsphundamentals@gmail.com. Bye for now.